To więc zaczynamy, bo myślą niektórzy, że nic się nie dzieje. Także tak, najpierw zaczynam po polsku i proszę Państwa, witam wszystkich serdecznie, z niektórymi widzę się, właściwie ze wszystkimi widzę się po raz pierwszy, bo nawet z tymi, którymi miałam przyjemność rozmawiać, to tylko głosowo. No, mamy przyjemność gościć dzisiaj firmę AntMicro poznańską, ale międzynarodową i pana Karola Gugałę, który opowie o tym, czym się firma zajmuje i open source'owo, tak? Głównie open source everywhere. So hello everybody. So if you don't know me, my name is Ewa Łukasik, and I have the pleasure to invite Mr. Karol Gugała from AntMicro, Poznań, located but internationally renowned enterprise AntMicro that is a very strong supporter of embedded systems in various configurations and for various applications. And the title of this presentation is Software, Hardware, Cloud, Open source everywhere. So the floor is yours.
Thanks.
I switch my camera.
Okay. Thanks for the introduction. Hello, my name is Karol Gugała, and I would talk to you today. I will give you this lecture about how what we do, how we do things, and how you can actually do things in your actually starting careers. So before this lecture, I've been asked to present what really a young engineer should know about working in modern embedded systems in a company like ours. So this presentation is more or less about that. Open source is a really important part of this. That's why the title, open source everywhere. But let's start from the beginning. What is AntMicro? So AntMicro is a private company founded 11 years ago, 2009. What we do, we basically develop like systems, very modern system, very new technologies. We're not really interested in the old stuff. We're on front of the technology development in the world. We are software driven, so even if we do hardware, we do it in a software way. I will try to explain it a little bit today on today's lecture, so you understand why this software approach is that important. I will also present a few examples of the projects we did and tell a lot about the way we work and why it's giving the results. Okay, so we are members of leading open source initiatives, which is Zephyr Foundation, RISC-V Foundation, probably heard of. I'm pretty sure you heard of Linux Foundation, and there is also one additional Chips Alliance, quite new. We actually participated in creating of this one. We have offices in Poznań and in Poland, in Poznań, in Wrocław. We also have Swedish office in Stockholm, but let's focus on the Polish ones. So in Poznań, we're in Baltic, so it's the city center, one of the highest building in this part of the city. Right now, we're on 12th and 15th floor. Well, this 15th floor is currently under renovation. By the end of the year, it should be done and finished, and we will be able to use it. But 12 is fully available right now. Also, we have some offices in Concordia, which is a building next to Baltic. So those two buildings together create, I would say, a small AntMicro campus in the city center. In Wrocław, we have offices in also in the city center, which is which is this building. It's really near the train station there, if you know Wrocław. It's Komandorska 12. Not sure if you know it. And recently we opened a brand new office in Wrocław Concordia, and it's located on a very nice Wbudowane island. And this is real photo. It's not a render. That's how it looks like. I think that's a pretty nice location for our Wrocław colleagues to sit in the office and work there. That's how it looks like. And that's how our Poznań office, 12th floor, looks like inside. This is a real photo from like entrance perspective. So this is the place where we basically do all the things I'm going to talk about. Of course, right now we mostly have to work remotely, as we have this lecture remotely, but I hope within the next few months we'll get back to the offices, and so we'll be able to again use this cool space there. Okay, so let me now show you a few examples of what we do. Just a few words of introduction to that part. We often do like end-to-end solutions. So basically, our customers come to us with an idea. For example, I would like to create a device that will bring me coffee in the morning, and I have that kind of a timeline, that kind of a budget, and I just want to have it. In our internal R&D, we basically try to figure out what technologies are available, try to follow the trends, try to see what's available, and also try to figure out what will be available short term. So we, having this knowledge allows us to basically tell the customers, like, let's use that, and that. Let's go this way. Let's follow those trends. And today we can start with a prototype using this, but in 2 years you'll be able to reach your goals and be even better. So some of the examples of the projects we did. This one is I wouldn't call it crossover, but maybe like the composition of a device. And this device is a 3D skin scanner, portable 3D skin scanner. And basically, that one is used by physicians to just scan patients' skin. And this device runs some AI algorithms and just tells the physician, tells the doctor that certain parts of the skin, certain changes in the skin should be examined further. Yeah, like it cannot tell you like this is a cancer or not, but it can tell you like this looks fishy. Just check this further. It may grow in future to something more problematic. Other example is like real-time detection system. So this screen here is actually a screenshot from a system we built in our office. That was a small edge is like embedded device running also AI algorithm. In this case, that's a detection algorithm. So it was able to classify up to 60 types of objects in real time from a video feed. And here you can see a view from our office on 12th floor in Baltic, looking towards the city center. So this is Academic Bridge, one of the exits of Kaponiera roundabout, and you see that this algorithm was actually able to detect and mark people, cars, buses, and all that stuff. Yet another example is industrial vision system. So here you can see a close-up of one of the devices we built. This one was actually used and is used for tracking basically stones on conveyor belts in mines. So you can use this device to just look at conveyor belts and figure out where are the stones, and then try to sort them, or do not gather useless waste stone. Yeah. And this device was actually using, we implemented that using FPGAs and combined that with NVIDIA embedded platforms with GPUs for running the algorithms and so on and so on. So that's pretty complex device, and that was pretty neat to have it running, combine all the pieces together. Since we were with RISC-V from the very beginning, we're actually a founding member of RISC-V Foundation. We do a lot around RISC-V. So we helped develop some tools to help develop some hardware with RISC-V, and we do a lot of services around RISC-V. So RISC-V is pretty new technology, but quite well adapted, I would say. And a few years ago, it required a lot of work around tooling and all those things that normally are taken for granted. Right now, it requires a lot of work around some higher level software, plus more and more adaptation requires some services around RISC-V. And since we are from the very beginning with this technology, we know a lot. We even helped creating some standards in this area. Beside regular embedded systems and those small systems, we also create bigger setups, like for example AI engines. And here you can see one of our developments, which is a drone tracking system. So that one can basically detect and track drones even from like a few kilometers. That's pretty awesome. And if you Google this name, you can actually find some video footage presenting how it works. We did some work in space area. Some of our designs, some of our devices and software is actually orbiting the Earth, sending some pretty neat video streams from above, from Earth's orbit. Plus, pieces of our technologies were included in some satellites, in some more complex systems, and they are flying somewhere around there. One of our in-house development is, I would say, this is one of the biggest in-house development that we continuously work on, is a platform called Renode. Renode is a emulation platform that allows you to run software which is normally run on embedded devices, on small microcontrollers, smaller or bigger microcontrollers, and Renode allows you to run it in an emulated system. So you can run unmodified software without the hardware, which is really cool. I will explain later at the end of the presentation why it's so important to have something like that. And we originally developed Renode as our internal tool to help us with in our work, and later it evolved to a standalone tool. Then we thought that it may be useful for other people, so we actually open sourced that and released to the world. So basically, Renode allows you to build virtual platforms from a very low level, from like a system on chip level, where you define a CPU and some peripherals that are inside a chip. Use this chip to build something that's called device, which is a chip plus some additional peripherals like external sensors, maybe some display, maybe some button, LED, USB interface, and something like that. And then combine those devices into complex systems. So, for example, create a network of IoT devices where you can run, virtual network of IoT devices where you can run the software. And this is pretty neat because you don't really have to, if you want to like test your software, test your algorithm on those embedded systems, you don't really need to modify it for testing. You just run the original software, and you don't really have to, for example, reprogram 50 devices like manually and try to set up a network together. Here you can just do it with one script. That's pretty useful in the end. A few words about me. I work at AntMicro since 2011, so it's 9 years right now. At this moment I'm leading a software team. I would call it like that. In software team, we basically work on all the low level. All the software starting from very low level, including even designing some CPUs, running some low level software, including porting operating system, adding some stuff, up to high level things like AI algorithms or video processing algorithms on those systems that we design. So basically that's a full stack, but in a way that from CPU design up to even some web services running on those devices, something like that. Yeah. I originated from a software world. I mean, I consider myself as a software developer, even though I very much like working with digital design, so FPGAs and all that stuff. That one often requires some hardware thingies, but I still consider myself as a software developer. Before I joined Micro, and actually at the very beginning when I was working on Micro, I was also working on a university, but that was quite some time ago, I think. And above all those things, I'm a huge fan of open source. So this presentation, even from the title, you can see that open source is really important here. I will try to explain to you why is it open source for like being effective software developer, being effective engineer. Why is it really good to use as many open source approaches, as many open source solutions as you can. So I hope after this presentation you have like a briefly idea what open source is about and why it's so important and why the world is driven by open source. So let's get to the point of this lecture. What to do to be effective engineer, how to develop cutting edge technologies, how to work with those technologies. But to understand that, let's first discuss a little bit how the world actually works right now. What you can find if you start looking at how to do things, and why most of those information that you can find how to do stuff is bad. Why you shouldn't listen to them. Maybe you will get some idea how to distinguish between good and bad approach after this lecture. I hope it will it would shed some light on what is bad in the current what is bad in engineering world, and what type of projects, what type of technologies you should avoid in your career. So let's start from status quo. So status quo, the technology is changing. Yeah, you probably heard of Moore's law. Moore is one of the founders of Intel. I'm pretty sure you heard of Intel. And many years ago, like in 70s, the law was stating that every 18 months, and the number of transistors in the CPUs generally in integrated circuits doubles. What does it mean? It meant that we had an exponential growth of computing power. So first of all, when you developed something, you had to think of, let's now try to use all the resources we have, because in seriously 18 months we'll have way more computing power, so we'll be able to do way more things with the same, on the same machines, basically. I mean, just by changing the hardware. So we don't really have to care about resources, and we have to think to the future. But this law doesn't work anymore. So for the last 10 years, the CPUs are not growing. So one can say that we have all the technology we can. We will not be able to do anything better, anything faster until we have any breakthrough in technology, in the hardware technology, in CPUs and so on. Maybe quantum computing will save us, but basically there's nothing more to get from the status we have. And no matter the fact that Moore's law is dead, we still have some pretty neat development. So 2017, NVIDIA presents self-driving car, and it works. It was 3 years ago. Then 2 years ago, Google I/O keynote. Not sure if you've seen that. If you haven't, please do. That was a pretty impressive keynote during which they used an AI algorithm to call a restaurant and book some tables, and even the AI was even able to basically talk to a lady which was barely speaking English. To be honest, I wouldn't be able to understand this lady. I wouldn't be able to actually book a table, and this AI was able to do that. So that was pretty impressive, and they did a live presentation. Later the same year, we sent Tesla Roadster to space. Yeah, so that was the test flight of Falcon Heavy from SpaceX. The same year, Boston Dynamics presents this walking robot. Pretty impressive. Still, 8 years or even more after Moore's law is dead. News from 3 days ago, Tesla announces full self-driving cars. So beta testers are now being released to Teslas in the United States. Full self-driving means your car may be in the other city, you just call it and it comes to you by itself. So that's pretty awesome. So we're pretty close to the things we've seen in science fiction movies. Like we just enter a car, it drives you somewhere, you just go to a party, and the car goes by itself to home, or something like that. Yeah, that's pretty cool, and it's already there. We're there. A few weeks ago, Elon Musk presenting Neuralink, which is the chip. In the presentation, it was implanted into pig's brain. So basically, we have technology right now that allows us to directly connect our brains into the network or things like that. Yeah. So it all happened quite recently, while Moore's law is still dead. So no matter what many companies say, or many people are saying, that since Moore's law is dead, there is no progress in technology. As you can see, there is. And for comparison, this is one of the top models of phone from 2009. So the very year when AntMicro was founded, and that was Android 1.6 on that kind of a phone. So you can compare that to what you have right now in front of you or in your pockets, and that was just 11 years ago, not so far away. Yeah. So when you are thinking about your careers, think about those few slides I just showed you, and this last one from this part, that was only 11 years. and it changed a lot. And you have like 40 years of your careers in front of you. So if you want to be successful, you have to stay on top. Next part of status quo, what's the world, how the world looks like, what will you hear if you ask or if you Google, if you try to read some materials, you may find all those things that I mean, how people work, how they should work, and you may even have some colleagues, older colleagues that will tell you that this is the way people should work. Because that's how it is right now. So how people work in many companies that do embedded systems. First of all, they use ancient technology. Why is that? Well, there's a few reasons. Like, people are lazy; they don't want to learn new things, which is obviously a mistake. You basically cannot skip this part. Technology is changing really fast, so you cannot stick to some older stuff, but people do that. Also, people tend to think like, it works, why should I change it? It's not, the best thing to do. If you want to be successful, if you want to be on top of things, adapt to changes. Do not deny the changes, just adapt to them. Second thing, source control. I've been working in previously on university, right now at AntMicro. So I kind of met a lot of people working in a lot of companies, talked with them, talked to them about the way they control, they store the source code and so on. So seriously, a lot of companies that claim that they are really on top of things and really innovative and so on, they handle teamwork as like seriously by shouting to each other, hey, I'm going to use this file right now, or I'm going to modify this piece of code. Please do not modify it at the same time, because we will have two different versions and we will not know what to do. And that's kind of, I would call, not even 80s, it's like 17th century, where people were just writing things and they seriously couldn't do it better. Right now we have a bunch of technologies that allows you to do that, yeah, to handle source control and handle teamwork efficiently. So if somebody is telling you that, okay, we have this very ancient source control system, or we don't use a source control system, that's like obviously wrong, period. You may also hear that narrow specialization is good. Yeah, so you should you should focus only on the thing that you're working on and nothing else. And again, this is not something that is true. I mean, nowadays, companies nowadays, engineers, and a lot of people, it's actually doing that. They doing only their thing and nothing else. They have no idea what it's all about. So for example, I'm doing my piece of driver and nothing else. And that's wrong. That's obviously not something you should do. If you are working on any project, try to think a little bit wider. Try to think of the whole project. And even about where the product will be used, how to reuse the code later, and so on and so on. So you probably will see that during your career, this narrowization, yes, this weird specialization, and people will be telling that that's good because you're getting better at one thing, but in fact that's not. And getting back to what I said before, you have like 40 years of your careers in front of you. So if you specialize in one thing, that thing may not exist in 20 years because it won't be necessary later. And the last thing in this how people work part, And this is really painful thing, vendor lock-in. So a lot of companies, like hardware vendors or toolchain vendors, software providers, they try to lock users in their ecosystem. So, for example, if you're quite advanced in your academic career, in your studies, so you probably started working on some hardware related things, on some maybe microcontrollers and something like that. So if you look at what one provider tells you, it will always tell like this is a special tool chain for my chip, and the other vendor, the other chip manufacturer will tell you the same. This is the special tool chain for my chip, and you have to use this piece of software. And to be honest, that is not true. Often those hardware pieces are the same, or they differ in some minor things. But vendors will really like to lock you in their ecosystem. So they would really like you to think like, if I'm using hardware from vendor A, I cannot really change my design, my approach to vendor B. And at some point, if you start following their marketing, following their the ways, the things that they are telling you, like you have to use my software, you have to use my toolchain, you will integrate that with your products, with the projects you're doing, you will have no choice. You will be locked in. So vendor lock-in is a real thing in the world. It's very dangerous for, if you want to be innovative, if you want to be successful in your engineering career, try to avoid that at all costs. Try to understand the wider picture and try to see, I would say, this marketing mumbo jumbo that they are trying to tell you. The next thing that the next problem that is actually killing the industry is a low quality. And this low quality is not like people doing that on purpose. It's often because people don't know how to do things better, or don't care how to do things better. And I would like to show you a few examples of that. You might be heard of this little fella. Those were cloud pets. I mean, this little this teddy bear is powered with some microphones, with some IoT tech, and it was supposed to listen to like children, upload all the stuff to cloud, and parents should be able to just log in and check what children are doing. But problem with this bear was that it barely had any security layer. Yeah, so it was really easy to break into the system. Seriously, you just run a script and then you could break into the system and listen to people. So that was the problem with that one. And of course, that's just an example of the technology issues that we deal with right now. There is, the quality of the stuff that you can find is often quite bad. So of course, in your career, try to not do that. And it also may come because of the vendor locking, because of the not understanding the technology you're using, because you just take things for granted. Like vendor told me that I should use this library or this piece of software and it will work. And if you don't check it, if you don't know what you're doing, you may end up as like this bear. So you may think like, okay, bear is not, maybe it's a problem for privacy, but not really, like a problem for humanity. But this way of thinking, infects all the parts. So if engineers working on the burrs, on this technology from the burr, used in those steady burrs, think like that, this way of thinking infects all the industry, and even such critical industry as as planes. You heard, I'm pretty sure you heard stories about latest Boeings. They cut some corners in software development, in testing, and so on, and actually that led to some serious problems, including plane crashes. So this way of let's just use ready things. Let's not think about what's inside. Let's just blindly follow things may lead even to those things. And that doesn't really end at the software level. It also affects hardware. So recent, quite this is also the list here is a list of quite recent CPU side channel attacks. So you probably heard of Spectre, Meltdown, Zombie Load, Foreshadow. Those are a little bit less known, but those are actually similar problems to what we see in software, but on a hardware layer. It's also cutting corners, it's also reusing things that are taken for granted, not understanding what we're doing, or focusing only on my piece of the project, not thinking about the rest, and so on, so on. And that all that leads to all those problems. So from all the examples I just showed you, it looks like computer science is really difficult, and it's really hard to do something very good, very innovative, and to be successful. So how to be successful? So after all those negative things, maybe I would just tell you a story about some positive, some kind of a positive story, the Instagram story. I'm pretty sure you all know Instagram as it is right now. So originally Instagram was founded in 2010, and 2012 it was bought by, it was acquired by Facebook for the astonishing amount of $1 billion. By that time, Instagram was employing only 13 people. So how was it possible? How was it possible that a small company of 13 people developed something that was worth $1 billion, and the other company actually thought that, okay, it's worth investing this $1 billion and buying this technology? So how was it doable? So if you look at the stack, software stack Instagram used, you notice that they basically used many ready things. So how does that correspond to what I just told you? That reusing ready things and taking things for granted may end in like plane crash. If you look at the stack, at the software stack here, most of the components there are open source. So why is it different than raising those vendor blobs, for example, vendor provided proprietary things? It's different because if you have an open source piece, you can check what it does. You don't have to believe anybody that it does what a vendor says. You basically can spend some time, check the code, and see by yourself what's there and how it works. And even if you find that it doesn't work as you wanted, or you find some bugs, or you would like to have a new feature, you can extend it, you can fix it, you can do whatever you want. And using open source as Instagram did, took them from like square one to $1 billion company in 2 years because they basically use that. So if you want to be successful, do reuse the stuff, but do not believe anybody, basically. Do not maybe maybe that was not the best sentence. Maybe know, not believe. Yeah, that's best sentence here. Yeah, and open source actually allows you to do that. It allows you to know and not believe. So that's, you know, Instagram story is a pretty nice example of how open source can work, but how does it correspond to embedded systems? Yeah, so let's check how it works in for typical Edge AI stack. So what is the typical Edge AI stuff? For those who are not familiar with Edge AI term, Edge AI is basically AI inference, AI algorithm run on some embedded systems. So how does a typical Edge AI stack look like? It doesn't, unfortunately. And this is because the industry is kind of as it is. So, you know, most vendors do they follow this path of vendor locking, they follow this path of not doing things in open manner and provide just you know, proprietary thing. But that can be changed, and we try to change that. We do completely different. We have a completely different approach to the technology, to what we do, to what we contribute to the world. And I would like to show you a few things how we do stuff. How all those things that are not so good in the world, not so nice in embedded system in computer science industry, how they can be addressed, how they can be approached in a different ways. And I will split this part into three main sections, which will be hardware, software, mostly focusing on embedded software, and at the very end, cloud systems. So let's start from hardware. The classic way, if you ask like very experienced old, I mean, forgive me this old, I'm kind of old, but you know, very experienced hardware engineers, they will tell you like you have to use you know, this known to work established tools like, for example, Altium Designer, which costs a lot, and you cannot really freely use it, because that's the biggest problem. Cost is at some point doesn't really matter. If you have money, I mean, your company has money, cost is like a minor problem. The problem is that Altium Designer on all those blobs, you cannot freely use them. Often you have a dedicated computer for those, so so that's the biggest problem there. And those experienced engineers will tell you you have to use that. Second of all, you have to use binary blobs, which are proprietary things from vendors, because that's how you do it. You shouldn't even think about what is inside. You just take it for granted and use. And I previously showed you what can happen if you blindly believe this if you blindly follow those statements. Every single design is sacred, and you have to keep it in secret, because you know all the other people will try to steal it from you, so you have to do a proprietary things and try to hide it as much as possible. There is no way to share knowledge or share the work between designs, and so on and so on. Yeah, so that's the classic way. How do we do it in a micro? So let me tell you about it on this example, on example of AntMicro's Jetson Nano baseboard. So this is one of our hardware projects we did in a company. This is a baseboard for NVIDIA system on module. This baseboard is basically the whole device allows you to use it in any like embedded system. You can deploy it in a drone or use whatever you want, and it's pretty powerful. I mean, it has a CUDA enabled GPU, so you can run even like quite advanced video processing on it, quite advanced calculation. It has AI accelerator, so you can use it for some intelligent processing, I would say. Yeah. So we did this board, and the main purpose of this board from our perspective was just fast prototyping. So basically you just grab it, do like a very fast proof of concept on this unmodified board, as you just use it as it is, and then you take the design and adapt it for your needs. So often if you want to use that kind of a board, for example in a drone, you don't need a USB or Ethernet because that doesn't make much sense there, but you need like 4 cameras, for example. So you just need to modify the design to allow you to connect 4 cameras to that one. Yeah, but if the design is open, if the design is proprietary, if it's closed source, you cannot really do that. So if you buy that kind of a device from some kind of a old school vendor that makes all the stuff proprietary, you can of course do a proof of concept on that, but that's all. You cannot take the design and modify it and adapt it to your needs. If you want to have something more tailored for your needs, you have to start from scratch. You have to design your own device. So from our perspective, that doesn't make much sense. The idea of get the board as it is, do a proof of concept and then adapt it wouldn't work if it wasn't open source. And it is. If you go to our GitHub, if you type in if you look for hardware projects there, if you type in JSON Nano baseboard, you will find all the sources, all the designs, all the files that are required to build this board there on a permissive license, so you can even take it, modify, and do whatever you want. And not only is it open source per se, it's built built-used open source tools. In this case, it's KiCad. So we throw away Altium Designer, which is the most popular proprietary CAD tool for designing PCBs, and we switch to KiCad. And if you talk with like old school engineers, they will tell you like, this open source KiCad is like poor man's PCB design software. And I'm pretty sure you can find like some areas where Altium is better, and that's true. Yeah, the Altium is in many ways, in many areas, better for designers. But there is one problem with Altium: you cannot really do whatever you want with Altium. With KiCad, you can do whatever you can modify it. You can modify it freely. You can script it. You can include it in your like custom build systems and so on. And that's really hard with Altium because it was never designed to work like that. Moreover, its licensing does not allow you to like run 20 copies of this software. And if you have like a server for building and rendering PCB layouts, PCB designs, you never know if the server will not run 20 copies of that, and they will just start failing. You may think like, why do we actually why are we doing open source hardware? So I kind of told a few arguments for that, like just grab it, do a proof of concept, and then you can freely modify it. But also, we do not really consider like most of the hardware design itself as a product. what is valuable from our point of view is a knowledge how to use it, how to do it. This is the difference between, like, for example, in operating systems, there was a similar situation there, or in tool chains. Like 20 years ago, operating system was a value. Right now, it's not. Right now, it's the value is how to in all the things around operating systems. So, for example, Linux is free. Windows is Microsoft is offering, free updates for a newer version. Even they realize that operating system as it is not really valuable. Google is giving its open source, its Android system for free to anybody who wants to use it. The value is in the services around. So we think in the same way about hardware, and the value is not in the design, in a single design. The value is in know-how how to do it, to this design. And just by grabbing a repository, nobody would steal that from us. Yeah. So it takes a lot of years and a lot of time. I mean, a lot of will to get to the point where we are, and you have to have this certain mindset to basically be able to compete. And because of this approach, we a few years ago, along with Google, with Sci-Fi, Western Digital, we established a Chips Alliance organization, which is basically which goal is to promote open source approach to hardware design, from very low level, from chips design to through PCB design to like whole systems design. Yeah. And speaking of chips design, this part of the ecosystem, this part of the industry was proprietary for way too many years. And earlier this year, like literally 2 or 3 months ago, along with Google, along with Fabless, a few universities, with Chips Alliance and FOSSI Foundation, under auspices of Chips Alliance and FOSSI Foundation, we helped Google to open source very first PDK, which is a process development kit for a 130 nanometer process for chip manufacturing. This process development kit, it's basically a set of, I would call it, libraries for that you need to build your chip. If you design your even digital design, if you want to do it in a silicon, you need this basically. That translates, for example, how a single logic gate should be realized in the silicon in the process of doing chip. Yeah. So having that right now kind of allows you to go open source from the very bottom to the very last part of the system. Okay, so we know how it works in the hardware. So let's take a look at the software. Classic way in embedded systems is it's hard to test. It's hard to develop. You have to click. You have to follow what vendors tells you. You have to use this binary blob, this proprietary part of software. You cannot really script it. It's hard. It basically, you cannot version the code and so on and so on. So nothing we can do. We're there. We're kind of work as if it was 1980. So what we do to make it better, to make it faster, to make it more effective, to make it successful? First of all, version control. That's a must, period. If you do not version your code, if you do not control, if you do not work in team, if you do not do code review, if you do not follow all the modern computer science or software development practices, you're basically not going to achieve anything. You're going to be stuck. And if you're stuck, you're basically you're gonna diminish. Yeah, you're diminishing. So second of all, you need to understand your tools. Again, period. So in our workflow, it's very important to first of all understand what are you working on, what kind of software do you use. So even if you compile, like if you work on an application, understand the rest of the system, like startup code, what happens around, and so on and so on, because your code is not standalone. Your code will correspond with will talk to the other code, and so on. There is this second bullet here. IDE is good as if you can work without using them. That one is kind of important, especially for people who just start working on those design, working in this industry. If you go to any like vendor and just read quick start guide, they often tell you like, get this IDE, write the code here in this window, then click this, and magically it will happen and will deploy to your board, and you will see the software running. That's cool as a first start. That's awesome if you know what's happening there and you're using that consciously and you know what happened underneath. But that's really bad if you really don't know what's underneath it, what kind of how the software compiles, for example, how it links, how it starts, how it boots, all those things that are really necessary to understand, because only if you understand that, you'll be able to innovate, you'll be able to follow the trends, know what's available. So again, do what people did during the times where Moore's law was still true. It was still true. Just to work on what you have today, but think of what you will have like in the next few years, or in the next 20 years, or in the next 40 years, because only then you will be able to basically do the best things and be successful. And of course, check what changes in the industry, follow the trends, use for example, new platforms, new computing platforms, like this one. This one is NVIDIA Jetson Xavier AGX, which is kind of powerful. I mean, this has a computing power of a PC computer from like 3 or 4 years ago, and it's in a form factor of like 1.5 credit card. So you can easily deploy it on some kind of a mobile device, maybe not mobile as in phone, but mobile as in autonomous car, or like racing car, or a drone, or something like that. And that wasn't really available, even this 11 years ago when we started in Micro, but it is right now. So 11 years ago when we were working on software, we were thinking of, okay, in future, technology will get miniaturized and we'll have like computing power of a PC in this kind of a form factor. So, even if the software back then was slow, we knew that at some point it will be faster. So you also have to do that. You have, again, 40 years of careers in front of you. You have to think at least a few years ahead. Use operating systems, open source operating systems, and open source platforms. Often in embedded system, there is every vendor, every like old school engineer will tell you, use a bare metal application or very simple software, and yeah, sure, it will work. Why not? I mean, that's okay. But if you're not using operating system, you have to develop everything from scratch every time you start a new thing. If you switch to use to the operating system, especially open source operating system, where you can really adapt everything, you will be able to reuse your code. And once you will be able to reuse your code, you don't have to reinvent the wheel over and over again. if you're doing what's getting more and more popular right now, which is this AI processing and vision processing on embedded platforms. That's mostly because they are more powerful. Also use open source technologies there. Do not follow, whatever vendor told you. This is our super cool proprietary library, that within 2 clicks give you some output. Use that because those technologies like OpenCV, like TensorFlow, once you develop something using that, you will be able to reuse that later. In terms of like computer architectures, CPU architectures, RISC-V is the future. If you look at the market right now, how many adopters of this technology, of this architecture is there on the market? It's huge, and all the biggest players are there, like NVIDIA, like Google, like Western Digital, and so on. So it's not yet popular, but it will be in. I mean, it is popular in like academic stuff and R&D stuff, but it will be everywhere within the next probably 5 to 10 years. So, like at the beginning of the careers. The same happened with ARM at some point a few years back. It wasn't nowhere, and now it's everywhere. Every single phone has an ARM CPU. And for those who are not familiar with RISC-V, that's an ISA, which is instruction set architecture. So it defines only instructions. It doesn't define any particular implementations. And on contrary to ARM architecture, it's open source. So basically, you can build your own RISC-V CPU without asking for permission. That's why it's so widely adapted, because companies are free of some binding contracts with architecture vendor. This is just an example of a quite recent piece of technology, RISC-V based technology. This chip here is a quad-core RISC-V CPU with an FPGA in a single chip. This one comes from Microchip, and we at Micro, we've been working with this chip a few years before it was even announced to the market that it will be available, and we were developing Renode support for that. So before it was even released, people were able to work on software using Renode. Okay, the last part of this this last piece of this presentation in this part is about cloud platforms. And how do we at AntMicro approach cloud platforms and cloud computing? So for us, cloud is mostly for testing and continuous integration. So CI systems are widely adopted in a standard computer science and standard software development flows, and of course we use it too. That's usable for any software development, including embedded. And if you ask, again, old school embedded developers, they will tell you that it's hard. You cannot do that. You cannot really do continuous integration with embedded software. Why is that? Because they use wrong tools, or they don't understand the tools, or they use binary blobs or things, compilers that needs to be clicked, and it's hard to script a click. I mean, it's doable, but it's not that easy. I mean, it's way harder than just script things that are like command line only. So continuous integration is a must-have if you want to be successful in any bigger project. So you have to at least build the code to be sure that every piece of code is available for everybody in a repository. If the code doesn't build, there is no value in it, basically, because you cannot use it. So how can you use continuous integration in embedded system? So first of all, build the stuff, but second of all, test. How to test embedded systems in a CI environment, use Renode. As I said at the beginning, Renode is a platform that allows you to run unmodified software in a virtual environment. It's absolutely fantastic for testing the software you develop continuously on a server. Basically, every time you commit something to repository, there is a number of tests being run, and the tests just tell you just added didn't break the old features you added a week ago. So that's really, really important, especially in big projects. Who uses Renode? All the biggest, bunch of companies, including the biggest ones like Google, Intel, Amazon. They all use Renode for testing. So the key players, the most innovative companies, they kind of understand that. So if you want to be successful, do the same. Last but not least, when it comes to continuous integration, plan your deliveries. This means that never ever deliver or deploy something that was built locally on your machine. Local builds are okay for development, okay for testing, like local testing and so on. It's absolutely not okay to deploy the system from a local machine. Local builds are not reproducible. You never know, you never remember what was the state of your local machine like after a week. If I had something installed, if I did some modification in my settings, after a week I could have like install new package in my system, and that one installed some dependencies and bumped some other packages, so on. I may have used different tool chain and that modifies my software. So imagine a situation that later your device or the software you deployed somewhere is faulty, and you have to figure out what is the problem. If you built it locally a month ago, you will never figure out what was there. All those deployments have to be created. All those packages that you send to devices or deliver to your customers have to be created in a reproducible environment. And the only reproducible environment is a CI system, basically, because in CI system you may script everything to start from scratch, start from a bare machine, install every single dependency, build the stuff, tag it like that was built from this source, from this version, with this toolchain, and so on. And in the end, if there's something wrong, you can track it down, you can track it back, what could happen there. Okay, so probably you're curious how to start learning about those new things. So I provided here a bunch of links. I think I will just share you this presentation after I finish. I just have to go through it one more time and then sanitize if there is something that shouldn't be here, or maybe some mistakes. But here is like a number of links you can follow to learn about some cool technologies we use at AntMicro, and you can learn about different approaches to what you do, what you develop, or how can you address some problems that you're dealing with right now or in your future work. Yeah, so some operating systems, some tools for FPGA tools, some open source libraries. That's of course very short list. There is way more in the world, but you have to start from something. So if you found my talk interesting and our approach interesting, our approach to technology, like Micro's approach to technology, you may also find it interesting that we offer internship. We have a quite big internship program. So our interns basically work on the stuff that I just presented. Maybe not the stuff that we deliver to customers, but with the same technologies we use for the customers. So if you would like to work with that, learn this approach, please, you can always apply for an internship. So we're looking for interns in those key areas like embedded software, which is all those things from very, very small microcontrollers to Linux-driven AI systems, cloud developers, which is mostly DevOps work, FPGA developers, or if you are higher level programmers, we also look for C# programmers, mostly in Renode project. Yeah, so in the project where we develop this this open source emulator platforms. Why us? I think I kind of explained that. Why it is interesting to work with us. We're actually developing the technologies that other will use. So if you're interested in developing stuff, not just using it, it's us. And we love open source. So if you are also into open source, if you want to know instead of believe how things work, AntMicro is the best choice. How do you apply? First of all, visit careers.antmicro.com. There is a lot of information, what you need to know, what kind of technologies we care about, what kind of approach we care about, how the whole recruitment process looks like, and so on and so on. So we can all read it all on this page on careers.antmicro.com. There is even like brief description what you should expect during the recruitment process. So if you're interested, join us. Thank you. I think we have still some time, so probably I can ask some questions if you have some.
Thank you very much for the interesting talk, showing the philosophy of AntMicro and very many details concerning hardware and software used by your firm. But if you would like to have a look into common notes, because it's rather a long question concerning Linux.
Mm-hmm.
Can you see it?
Mm-hmm. Yeah, I mean, I just used a short name for that. Of course, that's GNU Linux and a bunch of. It's not even only GNU; it's a bunch of different layers there. But yeah, that's just for. That's just a clarification of like naming convention, but that's like that. Yeah, Linux is just a kernel.
Okay, maybe some other questions?
So I assume this very long stuff is about GNU Linux, so that's more like a comment, not a question. How can you tell one uses Linux? Kinda don't understand this. How can you tell one uses Linux? So isn't it obvious? Like if you're using oh yeah, that was a joke. Okay, sorry for that.
At the beginning, yeah.
Mm-hmm.
Yeah, I can do that.
Okay. Okay, so I don't see any other questions. I mean, this is very long comment.
Yeah, so maybe another volunteer. Volunteers. Well, maybe I will have a technical, technical, no, not so much technical, rather administrative question. If somebody of the students during the semester would like to ask the question or contact you, not only in the context of you know, of working with you, but you know, some hard software, maybe they will be preparing for their lab session.
I think the best person to contact will be Martyna. She's here with us, I think. If not, you have her email and contact info to her. The problem with me is that I have like way too many things on my plate. So
Yeah, but
if I get like bunch of questions, I may not be able to answer them in time. So I think the best person to contact is Martyna, and then we will distribute the questions among different people, and that may actually work.
But my intention was rather, if you would be interested in a cooperation on a very low level, for example, in the context of a very small, tiny project that had to be for the assessment of the lab session of this embedded system course.
I mean, it all depends on the projects. I mean, we do a lot of things I mean, in a company. So we can of course always talk about details of that. But yeah, why not? I mean,
because
sure.
you know, I'm not responsible for lab sessions. These are my colleagues, and I don't know what the students were told, but I know that they have to do a project. Yeah, I don't know. Maybe you could ask about this question, because you know, I'm I'm getting into your shoes. I mean, the students, just to only to know if some of those you know, very interesting pieces of hardware and software could be used for their project. There's something new in the chat.
I don't think so. Okay, so maybe the best.
Yeah, they are learning on Mitsubishi Alpha from 1998. That's true.
That's a PLC, I suppose.
Yes.
So it's always even worse. Yeah, I'm not a big fan of PLC stuff. PLC is this very old tech. I think that the picture I used to visualize old hardware was actually some kind of a PLC platform. Yeah. So.
Okay. Oh, but maybe you can show the Zarek something something newer. Yeah. Okay, so if there are no questions, so I'd like to thank you very much for this very interesting presentation. As I said, not only about hardware and software, but some philosophy that is needed. And what I find very important is that you persuade people to be broad-minded, not to specialize in only single activity. And also, what I found very interesting from this philosophy, that know your tool, because sometimes there is such a tendency of using the blocks of something and not knowing what it really does, and it concerns both software and hardware. And I think that you'll never know when and in which circumstances you may need this knowledge, what is inside.
And to be honest, if you don't know what you're using, you will never be able to win the race, I would say. I mean, if you just reusing what somebody else gave you without really understanding how it works, you will always be just copying something else. And if you're just copying, it's really hard to,
Not innovative.
yeah. I mean, that's like the opposite of being innovative, but it's hard to even be good at something if you're just blindly copying things without understanding. So yeah, that's the problem here, and that's why it is important to understand what you're doing. Basically, I think that's not only for engineering, it's kind of for everything.
Yeah, and that's why I am calling this philosophy. So once more, thank you very much. Thank you very much, Martyna, for arranging this. And well, have a good evening.
Okay, thank you.